All right, let's get started. I know it's after lunch, and hopefully you've had a good lunch, and the content that we're going to provide to you today will keep you engaged. This is session 410. I think I have the longest title. I didn't do a letter check, but it's certainly very long. Our talk today is about having metro-style apps, in particular real-time communication apps, and we're going to see how these are going to work in Windows 8 with the new process lifecycle management that we have. My name is Raghu Gada. I'm a dev lead on the core networking team in Windows. I love networking. I've been doing networking for over 10 years. I've worked on the networking UX. I've worked on drivers. I've worked on services. So I've been doing quite a bit of that. I'm joined today by Kamal Srinivasan, PM on our team. And we'll be talking to you about how to get these apps written. So I wanted to take a quick hand count of how many people flew in from your respective cities and you had a layover. OK, so a fair number of you. So I was coming in from Seattle, stopped over in Denver, and my plan was that I'd land, and I know that Denver has a great Wi-Fi reception in all the terminals, and I was going to open up my laptop, open up my Outlook, have it sync, and then go onto my plane, go into airplane mode, but I'll be productive. So that was my plan. The problem was that our plane landed a little late, and Denver airport's pretty big, so I had to go from one terminal, really walk all across the terminal and go into the next gate and get onto the next plane. So I didn't really have a chance to open up my laptop and have mail sync using the Wi-Fi connection. Now, wouldn't it have been good that as I walked through the terminal, I didn't even have to open up my laptop, but the mail client, for example, would connect to the wireless, and it would start downloading all that mail, so that when I did get on the plane, even though it was in airplane mode, I would still be able to be productive. So try and keep this scenario in mind as we walk through this presentation, and we'll see how Windows 8 helps achieve this scenario. So with that, let's get started. Here's the agenda slide, a very quick one. We're going to be talking about apps in Windows 8 in general, and we're going to be talking about real-time communication apps, and I'll use the term RTC from now on. We'll also talk about the philosophy that we have in Windows 8 for how these RTC apps are going to work. And so we'll talk about what it means for the user to be in control and how that is achieved. The meat of the talk is going to be about how you're going to build these apps, and we're going to be showing you a bunch of code snippets, and Kamal's going to be doing that part. And finally, we'll have a quick review. So you'll get to know how to build these apps that work 24/7. And if you're an app writer, that's great. If you're a person who's building networking hardware, your chipset, et cetera, we want you to understand the end-to-end scenario also. So it's important for all of us to understand how each part of, as I call the chain link, is going to work. And each one of this is important, from the apps down to the hardware drivers. So let's get started. The first customer promise I'd like to talk about is longer battery life. Everybody who's going into a Best Buy or your favorite shop is looking at these nice, sleek form factors, and not only has it to be appealing, but everyone's looking at the feature list and looking at, well, how long is this going to last me? Active use as well as standby use. So we all want this, and I don't know about you. I remember when I got my first laptop. That was in 1997. I was a grad student in Purdue University, and at that point, my prof handed me a laptop. This laptop was actually 8 pounds in weight. And it had a battery, and pretty much it was a mobile device, but mobility was constrained because I really had 2 wires coming out. The first wire would be the power one. Second one would be my Ethernet cable or my modem wire, which would be plugged in into the laptop. So it was not really mobile because of the fact that the battery wouldn't last more than like an hour or so if I unplugged it. We made certainly advances in battery technology, et cetera, and our devices last much longer. But this is a continuing trend, and as you've seen in various talks throughout the course of this week, we're really placing a big bet and a great emphasis on improving battery life. So that was the first customer promise. The second one I want to talk about is what I call always reachable apps. You've got these nice new Samsung Windows Developer Preview PCs, and you'll notice that they have either the weather app or the stock app. You didn't even activate or start this app, but you're seeing it provide you information, right? And this information is coming down as soon as things change. For example, the temperature changes, the latest temperatures available. It's really about what I call instant gratification. I turn on my device, I want to see the information available, up front and center. Syncing and doing all these kind of things, we're really moving away from that, and we want to have the information available all the time. Of course, traditionally, when we wrote such apps, we would want the app to be running, and if we have the app running, it can sync, poll, get push notifications, whatever. But the problem is, if every app started doing that, then we'd have a lot of apps that are running all the time. So if you have a lot of apps running all the time, our first customer promise of longer battery life suffers. So as you can see between these two things, there's a certain tension that's there and that we need to solve. So we'll take a look at how to address this tension. So in Windows 8, if you've gone to Ben Strower's talk, we reviewed how the new life cycle is for apps. And here's a quick diagram that shows the same thing. We have a running app when you activate your app, and there's a bunch of different ways you can activate your app. You have the running app, and that can move between running and suspended. If I'm using the app, it's in the foreground. If I'm not using the app and I start using a second app, the first app goes into the background, and I can move back and forth between this. As I keep using a larger number of apps, the system tracks that and decides that, okay, now the app that was being used at the beginning, maybe it's not being used. So there's, in this diagram, we show that, okay, we've got a low memory event, and the system says, okay, time for this app to go away. So we're controlling the life cycle of the apps. But at the same time, you've seen other talks which talk about tiles and notifications, which show how your app can still receive, at least it can look lively. It feels it's still reachable. And for this, we're using the new Windows notification service and the concept of push notifications. And that's great. It works nicely. Your app doesn't have to be up and running, but at the same time, it looks to the user that it is up and it's doing something. Let's consider a different class of apps, the RTC apps. A quick show of hands. How many of you use one of these three? Looks like you guys are all very social, and that's great. Yes, all of us use this. And let's review in each of these cases, what's the commonality? If I'm using a VoIP client, I do expect to be able to receive an incoming call whenever someone's trying to contact me. If I have an IM client, and many times the VoIP and IM client is the same, but if I have an IM client, I have the same expectation. I want my friends to be able to, it doesn't matter what I'm doing, I still want my friends to be able to send me IM whenever I need to. And of course, mail apps are ubiquitous. We've been using it for quite some time. Of course, we've moved from a model of like pop mail where I would do polling every so often I would get it, to a direct push model with, for example, Exchange servers. So EAS, the EAS Exchange Active Sync Protocol is an example of that. I do want, as soon as something lands in my inbox on the server, I want it to trickle down to my device immediately. So these are the user expectations. So the commonality here indeed is that these apps need to be always reachable. They need to be able to, even if you're in the foreground or the background, they need to be able to do their thing and thus provide the experience that the user expects. So we understand this, and we want to say that, yes, you will be able to develop such apps, and you will be able to develop these apps that are always reachable, and at the same time, we're going to try and address that tension. Remember that I talked about push notifications. We want most apps to use that model. I want to repeat that. We want most apps to use the push notification model with Windows, with WNS. But these class of apps have certain requirements. For example, it might be that the latency is a very critical requirement, for example, for a VoIP call. It might be that in the case of Exchange, the server is something that I can't change, and it already is existing, so I need to be able to communicate with that. So there are some restrictions in which cases that you cannot use the WNS push notifications, and we'll take a look at some examples. So we looked at the standard life cycle. This is the diagram I just showed you. Now let's see what changes with respect to RTC apps. So in Windows 8, we're introducing a new concept called a background task. A background task is app code. It is your code. So this background task is started up. It runs for a finite time, and as the animation will show, it goes away. So a start, a clear start, and a clear stop. Now when is this background task going to get executed? It's going to get executed whenever a system event is defined. We'll talk about what are the different types of events and triggers that are present. So every time a trigger fires, your background task will get to execute. And this way, we have an event-driven model. You decide for your app which one of the OS-defined triggers are important for it, and you register for those. And finally, when that trigger fires, your app code gets to execute, and then it finishes. So I talked about how we had this tension. But we defined how the background task works, and it sort of addresses it. But how does this look from the user's perspective? So let's flip it around. We know that Windows 8 is placing a great emphasis, as you saw in various keynotes and sessions, that we want the user to be in control. So I want to introduce to you our new lock screen. You're used to seeing this for the last few days. And our lock screen is an example of where we see that the user is in control. In this particular case, I can put up to 7 apps. And the first one is the detailed status one. In this case, it says, make awesome apps, build conference, et cetera. So it's the calendar app. I also see, towards the bottom, 3 other badges. These are indicating status of whatever those apps are. So in this case, it happens to be a mail one, the first one. Second one is the VoIP, and the third one is the messaging one. I can put up to 6 more, like total of 1 plus 6. And if you go into the control panel under your personalization section, you can see 1 plus 6 boxes where you can configure. There are a couple of ways of configuring this. The user can elect to configure whichever app needs to be there. And the second is, on first run, you as an app writer can use the lock screen APIs. I have references for these. You have the lock screen APIs. You write to the lock screen APIs, and when you need it, for example, on first run, there is a UX that happens. And with that UX, you will be able to go onto the lock screen. Now, why am I saying this? I'm saying this because if you are an RTC app writer, you do need to be present on the lock screen. If this is our way of allowing a user to tell us, like, hey, of all the apps I have, these are the ones I really value. I want you to give these guys special privileges. And so if you are on the lock screen, you will be able to use some of these, you will be able to write background tasks, and these background tasks will get executed. And as we will see shortly, Kamal will go through code snippets where that happens. So, everyone ready for a demo? Yeah, all right. So what we're going to show here is a chat client that we've developed specially for the Build conference. We will share the code out for this. We haven't figured out exactly how, but we will do that. On one side, I have on one side, I have the I'm TS'd into a machine which is running the chat app. And on the other side, we have a WolfVision which is showing us that we have an NVIDIA Tegra development board which has a Broadcom wireless chip in it. And these two clients are connected through the access point. Yes, it's a great set of audience. Wow. Let me see.
This is when you guys clap.
Okay, so let me say something. Yes. They are great. And you should see. So at this point, our chat app works, but in both cases, you're seeing that it's in the foreground. What we're going to do now is I'm going to try and use the keyboard to aspect ratio is not correct, but that's all right. Let's go to start. And let me start the task manager. Here's our new fancy task manager. And you can see, as in Steven's keynote, you can see that the apps are listed here. And you can see that, hey, the build app, which I also had running, is suspended, as is the Ping Me app. So at this point, we would expect that, oh, our app can't run, correct? And you saw that. You saw that although my app was suspended, my app was able to write some code, the background task, was able to execute some code, and in this case, pop what we call a ringing toast. And once we clicked on the ringing toast, we flipped back into our app. So this is an example of how you can develop apps that will do background execution as well as will get scenarios like RTC working. Okay, right? So no talk is a good talk without at least one architecture slide. This is really simple. So at the top, we have the three apps, in this case, VoIP, IM, and email. We're introducing three new system components which allow you to do this form of background execution. And this is the trigger model I was talking about. So the first one is a network trigger. So for example, in our IM case, we saw that a packet came across the wire and came up through the stack. And at this point, our Ping Me app had written code that, OK, once I have this packet come in, I'm going to start writing some code, and in this case, pop a ringing toast. So that's an example of a trigger, network trigger. An example of a system trigger is, for example, I log in, and that's a system event, and maybe your app wants to do something about that. We'll see some code snippets for that. The last one is the time trigger. This is an example of something that needs periodic activity. And we'll see an example of how to do that. I referred to PopMail earlier. All these three triggers are built on a new platform called the background task infrastructure. And so that's how we're able to get the apps working. So having said that, let's take a look at how we built the IM app. And I'm going to let Kamal talk from now.
Hey guys, I'm Kamal. The program manager was introduced first. So since it's after lunch, I'm going to try and go through the code as slowly as possible so you get a chance to see and not rush, right? So let's see how we built the chat application. So we showed you that when the application was suspended, you're able to get some notification, and when you clicked on it, again, the application got the message, right? So let's see how that worked in Windows 8. So first let me start with what's the user expectation, right? Because you're an app developer, the first thing you're going to do is that like you're going to figure out in your head, hey, what do I want to enable for my user, right? So you're going to think about, for illustration purposes, let me just set context. For illustration purposes, we're talking about IM, but as Raghu was saying, you can build a VoIP app, you can build an email app, say an Exchange Sync app, and we're going to walk through all the trigger APIs that we showed in the architecture diagram, right, with an example. But for this set of things, since you saw a demo in that context, let's walk through a chat app, right? So the first thing is, when my application is in the background, you expect that the IM reaches me. It doesn't matter whether the user is listening to music and he just put my application away from foreground, he still expects that he gets the IM, right? Sure. But what's the second thing? The second user expectation that we are telling is that like, when the user logs in to a device, you don't expect that the user goes and launches the chat application every single time, right? Because when they log into the device, then you expect that they get the IM messages instantaneously if somebody's going to ping them. So let's see through code snippets how you would enable this in Windows. So before going into this, I'm going to talk about the execution pattern for any background task in Windows 8. So if you're going to use any of these trigger APIs, the execution pattern that you're going to follow is going to be the same. So as an app developer, you're probably thinking, hey, I saw this cool demo, right? And I gave you a cue for you guys to clap. Next time when I do that, please clap. So you have this cool chat app. How the heck these guys built it, right? So is it a lot of work? No. You're going to do two things, right? The first thing, you're going to register for the trigger APIs. That's pretty much what you're going to do, right? So you're going to select, hey, I want to get this network trigger. When there's an incoming packet, I need that trigger to come to me. That was how we showed the IM app. So I need to register for that trigger. Then, once you've registered with the OS is going to wait for that trigger to fire, right? So this is nothing for you to do. You just call the API, and we know that you're an application, you're one of those applications the user has chosen, and all those good things. Now, once the trigger fires, now it's again your chance, right? This is where you tell, here's my background task, here's this snippet of code, and I want to run this code, right? So we'll see how you're going to specify a trigger and how you're going to specify a background task. Pretty much, this is what the execution pattern is for writing a background task, irrespective of the trigger API that you're using. Okay? So with that in mind, let's walk through some code, since you're all here for this. So the first thing I'm going to show is, like, how did we receive the IM when the application was in the background and it was suspended, right? So what we did was that, like, this is nothing different. If I have a chat application that uses networking, I have to connect my socket. So I open a socket, I connect my socket, right? And you see the namespace. You would have seen in other talks from different networking talks where we said, here's the runtime sockets API, and here's the new namespace, et cetera. So we're using the Windows networking sockets namespace. The next thing, this is the new part where you register for the trigger, right? So you create a notification channel. So this is a notification channel that you're creating as part of the RTC trigger. So this is the network trigger API that we're talking about, as you can see in the box on the top left corner, right? So this notification channel object is part of the same Windows networking sockets namespace. And in that, you see 4 parameters. You see a channel 1, which is a friendly name saying that, telling the OS that, hey, this is my notification channel, so here you go. The next 2 parameters are classes that we're going to talk through some examples and see what they do in the next set of slides. But I want to turn your attention to the last parameter that you have, right? This is the server keep alive time in minutes. Many of you have protocol-specific timeouts that you have to set for your server to maintain your client state. I'm sure many app developers here would have dealt with this. So this is for you to tell the OS that, hey, this is my requirement for you to make sure that my protocol-specific timeout is met. So that's the 4th parameter. So we're going to walk through and tell you how we make use of that internally. Okay? So for now, just say that this is the registration part. So you did the registration. Now you're wondering, hey, I created a socket. I have a notification channel. But how do you tie these two? We did think. So here's a using transport. So this is how, because you're an application, you're a networked application, you have probably many sockets. You need to tell the OS that this is the socket that I want you to maintain. It doesn't matter whether my application gets suspended. I want you to maintain this socket. So this is how you tie the using transport through the using transport method and tell the OS that, hey, here's my socket I created. Make sure that you keep this socket. And we call this as the control channel. Okay? So after you've done this, you've registered now. You're all set. The OS is going to wait for some event to happen on the socket. Now you need to tell us what is the snippet of code that gets to run when that event happens, right? So this is the snippet of code that gets to run. So here you see that this is part of the Windows application model.background namespace. And in that you see, I told you about two classes that you told the OS when you registered your trigger. So the first class is what you're seeing on the slide. This is the push notified task class. In that class, you're going to see an interface that gets implemented. That is the iBackground task interface. And in that interface, there's a run method. Now, if you're going to pay close attention, okay, you're going to see that this particular way of describing the background task is the same. You're going to keep changing the class name, but the iBackground task interface and the run method is common across all the trigger APIs. So for this particular network trigger API, you specified the iBackground task interface with the run method. And in a demo app, this is where we wrote the toast popping message. And when the user clicked the toast, we were able to go back to the application, and then we were able to pump the message back to the application so that the application still had the message, right? So this is where we handled, and this is how we enabled our demo to work. So now we walked through this. So what we've seen is that, like, I got my message. I was able to, through this control channel, and I was able to throw a toast and handle this message. Now, one thing that happens is that, like, if you're an app developer at some point in time, right, you would have dealt with keep alives. So let's walk through what a keep alive is, right? So a control channel is something that you have between your client and your remote endpoint. Now, if you have this control channel, there are, of course, intermediate network devices that sits between your client and your remote endpoint. And if you have these network devices, they typically have some form of state lifetime in them. And this state has to be refreshed periodically in order to make sure that you're reachable from your server to the client. If you don't keep refreshing the state, then one of these intermediate network devices are typically going to close your state or break your control channel. So in networking jargon, they refer to this as keep alives, right? Most of you would have heard of this, just a refresher. So there is a network keep alive interval, as you can see. And then we go back to the server keep alive interval that we spoke earlier, right? This is your protocol-specific timeout. The reason the color of these boxes are different is that, like, the server keep alive time is the hint that you give the OS. Traditionally, and until Win 7, if you're building an application that had to maintain this control channel, you as an app developer had to go figure out what is the timeout I have to put in order to make sure that my control channel is open from my client to the remote endpoint. Now, that was a lot of work for you. You know what you guys, some of them, like I've heard, have done is that, like, okay, I'm going to put the min of whatever I've heard from my clients. So some of them have put timeouts like 1 minute, timeouts of 2 minutes. It's a hard guess, but it impacts the battery life. So what we've done is that, as Windows, let's keep the customer promise in mind, and let's do the heavy lifting. So in order to do the heavy lifting, what we've done is that, like, we in the OS determine what the optimal keep alive time is between the client and the remote endpoint. So we handle the network keep alive time determination dynamically on the fly. It doesn't matter whether your app is being used at work or it's being used at home. We still determine what the optimal keep alive time is to make sure that, taking into account your protocol-specific server keep alive time, and we make sure that the control channel gets to be open, right? So now again, this is a trigger. In the registration of the notification channel, you specified the second class, right? This was the class calling keep alive task. So you already registered with the OS. Now you need to, again, like in the execution pattern, you need to specify what is the piece of code that gets to run when this keep alive task fires. So it's the same model. So you specify the class, the iBackground task interface, and you write the run method. In the run method, you say, hey, here's my message that I want to send whenever this keep alive trigger happens. So what we've done is that we've simplified your task of maintaining the control channel from the client to the remote endpoint. Okay, so by doing this, you made sure that the control channel was established, the control channel was kept alive, right? I told you about a second promise, which was the user login. So when a user logs in, you wanted the application to be able to establish this control channel and be able to make sure that your application is reachable when when somebody sent a message to you. So this is the second type of trigger API that we're going to discuss. This is called the system trigger API. Okay? So in the system trigger API, you have like multiple triggers that we've enabled. What we're seeing here is the session start trigger. There is a white paper that got published. It's called the Introduction to Background Tasks white paper. So in that white paper, you'll see all the triggers that we've enabled for you to be able to write. So let's go through system trigger and see some of the other examples that you can probably write, right? So in this, you've registered with us. The first thing you're going to do is that, like I told you, you have to register, right? So you're creating the system trigger type session start, which is the user login, really. And then you're going to do this background task builder class, which you're going to have. And this background task builder is part of this application model.background. And in this, you have a task entry point. This is where you specify the class, saying register for user login is the class that I want you to run, right? We're going to see the, how you implement the interface in that. And then you set the trigger. The trigger is essentially session start. And then you're giving a friendly name, saying on user present, you're going to fire this. Finally, you just tell the OS that, okay, hey, I've done all the entry point, and I've given you all the details. Register it. Now the OS is going to wait. When the OS trigger fires, when the user logs in, this is your application code that gets to run, which is essentially saying that, hey, register for user login was the class, so the OS knows what to go and run as piece of this. So you get to run your code. So boom. So we've met both the customer promises, right? So now what happens on a network change, right? Because I told you when you move from office to work, we were able to be able to log in and make sure you're reachable. And even in Raghu's example, where he was talking about his, when he was walking through this airport Wi-Fi, he wanted his mail to be up to date. How did we enable that? This is where you can establish, right? If you write a system trigger, one of the trigger types is network change. So if you register for the network change, and if it's a known network and all those, then you'll be able to execute code from your application to make sure that you're fresh.
And we have it in the background, the backup.
And it's there. There are some backup slides as part of this towards the end, where you can see snippets of how you register for those. But the execution pattern is still the same. It's just the semantics of the API that changes. So, okay, I've spoken enough, and I need a break, so let's go back to the demo table. And let's see, it's back to the same. Raghu, you can switch to the Wolf Vision.
All right, which one, this one?
Yeah, just the Wolf Vision.
Okay.
So let's go back to our friendly Ping Me app, right? But this time, on the NVIDIA Tegra platform, developer preview platform, and this is a platform. This is one of the few class of devices that supports this notion of connected standby. There have been like many talks through this week where you heard about connected standby. There was a talk by Pat Steeman. There was a talk by Andrew Ritz talking about like networking for connected standby. So this is one of the few class of devices, and thanks to NVIDIA for allowing us to demo here. So this is one of the few devices that supports it. And to make things interesting on this device, what I'm going to do is that I'm going to press the power button, right? So when I press the power button, if I can reach that, okay, boom. That's as expected, right? I pressed the power button, the screen went blank. No changes. So now what just happened is that the device went into connected standby, right? So the device is in connected standby, and when the device is in connected standby, the network connectivity is still maintained to your access point or to your mobile broadband tower. So, wow, somebody's trying to ping me still. Let's press the power button. Let's see who's trying to reach me. Oh, it's Raghu. Okay, this time it's time to clap.
Thank you.
All right, you guys are a great audience. So what just happened, right? We had an application. We put the device to connected standby, and even in connected standby, my application was reachable, right? So if on a regular PC, if you put the power button to press, your network connection is broken, your control channel is broken as a result, and as a result, your application was not reachable. With Windows 8, with the new connected standby feature, and with the capability of some of these devices, we're able to build applications that are reachable even if the device is in my bag. And as a result, the example that Raghu said of his mail app being up to date when he was walking through the airport, it can be realized. So let's switch back. Since you clapped, I'll show you more. Okay, wrong.
Presentation and lock screen. Okay.
So next. Oh.
Got the
So let's quickly review connected standby. How many of you went to any of the connected standby talks? Okay, there's some of you. So let's review connected standby, right? Because it's a good way to understand what just happened. So what happened was that we had this certain class of devices which support this connected standby, where even when the device is in this really low power, right? One of the goals was that as Pat Steeman in his talk mentioned, was that you wanted to maintain less than 5% of power consumption when this device is in the connected standby. So in order to be able to reach that, you need this really optimized network connections from your device to your access point if you're connected to your Wi-Fi. In this case, we are connected through our Wi-Fi. We have a private access point, and we are connected to this access point here. Or if you're connected to mobile broadband, because mobile broadband is a huge scenario push for Windows 8 if you have gone to any of the talks through the week. So if you're connected to any of these class of networks, right, you still want to make sure that your device is reachable. If your device is reachable through the network connection, then your control channel, if you do the things that we just showed, is also open, and it's always reachable. So hence, your application is reachable, and your user sees that you've built a great app, and we've worked together very well. Now, how does this work in connected standby? You as a developer, right? I see many of you are developers here. So you're probably wondering, okay, is there one more piece of code I have to write? Now, you guys are going to love me for this, right? Nothing special. We made your life simple. If you build your app on the new Samsung Developer Preview machines, it's going to be the same model that you're going to have when you get these class of devices that support connected standby, and your app is going to just work, right? So it's one model to stay connected, whether the app was suspended and the machine was running, or the app was suspended and the machine was in connected standby. So what we've seen up till now. So we've seen two trigger APIs. We saw how we built the IM app. We saw how we enabled that through the network trigger API. And we also saw how you could use the system trigger APIs. Now, some of you are probably app developers that need to build an application that is doing more of a polling mode, right? Because what we saw up till now was more of a push mode. So now, some of you are developers who just want to build a polling-based app. Say, for example, in this case, I put pop email as an example, right? Because it's something that comes to my mind easily. I set my device to say that, hey, I just want my application to go fetch mail every 15 minutes, every 30 minutes, right? So it's only a periodic update. I don't need to deal with all this control channel, all these kind of details that some of the other apps need. So if you're an app developer that wants to build a pop email, right? So let's walk through to see what you do for using the time trigger API, which was the other box which we hadn't shown till now. So periodic mail, I just described the scenario. The user expectation is that, like, hey, when I say to the application that go fetch my email every 15 minutes, it better go fetch the email every 15 minutes, right? So they do have that expectation. So how do you realize that in Windows 8, right? Whether your app is running or suspended, how do you do this? So register for periodic mail sync, again, back to code snippet. So you specify the trigger. I promised you guys that the execution pattern was going to be the same, and I'm just delivering on the promise. So we have the time trigger. So you specify the time trigger. We have a background task builder. And as part of the background task builder, you specify the same three things. You have a task entry point. You have the set trigger. And you have a name. And finally, you register the trigger. And what you're going to do next, you're going to write your app code to say, hey, here's my background task. Go fetch email, right? This is where you would have to handle this. So through the set of slides, we saw snippets of what you have to do. There are a few things that we haven't gone into details. In the interest of time and the interest to keep you guys awake, is that, like, we haven't gone through manifest declaration. We haven't gone through details as to, like, what kind of things can you do in the background task. We haven't gone into details that says that if you're writing background task, how do you make sure you're in sync? So all these kind of details are part of our white paper, Introduction to Background Tasks. And Hari is going to be here in the stage after the talk, so for more Q&A and kind of details. So we'll walk through those. So through these three trigger APIs, we believe that you can build the RTC applications that we had described. I'll give it over to Raghu for closing the talk.
So a quick review. We start off the talk by, I addressed this issue of tension, and that was for these two user expectations. I expect to have long battery life. This is a differentiating factor. We expect to have long battery life not just for active use, but we want also for long-standing connected, for standby use. At the same time, we want to use apps that are always reachable, fulfilling the instant gratification where the information is always available. We discussed about how Windows is addressing this. And from the app writer's perspective, we looked at how you will be writing background tasks and how we made it easy for you. We also looked at this new feature called Connected Standby, and we talked about what that means from the app writer's point of view. You don't have to do anything different. And as far as the network hardware manufacturer is concerned, as far as the chipset is concerned, the chipset folks should be looking at adopting the Connected Standby feature, and the network hardware manufacturers should look at Andrew Ritz's talk, where we talk about what are the requirements for that. And I come back to that chain link concept, right? If all of us do our respective parts, we can really wow the user in terms of having devices and apps that are really always reachable, and 24/7 really means 24/7. So a number of related sessions. We talked about, the first one was by Ben Srouwer, the fundamentals of Metro-style apps. The second talk is Pat Steeman's talk. The third one is for network hardware driver writers. And then the 785 talk is really about what it means to write good networking apps. I just put that in there. And lastly, for most apps, we expect you to use tiles and notifications, and this is the other talk for that. So with that, I want to thank you all for coming here. And you can, we'll be available for Q&A right now. So if somebody has questions, please come forward to the mic, and we'll address that. Thank you.
Thank you. So it looks like There are two takers.
Yes, please go ahead.
Sure.
Just a quick question about, you had showed a demo when you were running under connected standby, but just in general for running under lock, how much are you actually able to notify? Like I saw you played a sound there. Are you able to do can you show a visual notification? Can you actually wake the screen if it's asleep or?
Thank you.
Sure.
So the question was about what are the things that you could do using the Toast APIs.
Yeah, pretty much.
Pretty much, if you're writing a background task, our expectation is you do not throw front-facing UI. The only thing you can use is use the Toast API.
Okay.
And we have folks in the audience here who, if you're interested, particularly for that, I can.
Yeah, I'm more wondering like under lock. Like if it's under lock, can you show? Does it do?
So it doesn't matter what state your app is in.
Okay.
Your background task will get to execute.
Okay.
Right. And again, in the background task, pretty much the only thing you can do as far as UI is use either the ringing Toast or the the regular Toast.
Okay.
Okay. Next question.
Yeah, a couple questions on when apps register for the keep alive callbacks and the background timer task.
Sure.
Do you have any guidelines or enforcing restrictions on how long those can run in the applications?
Yes.
And maybe you say it in the white paper, but can you talk to
Yeah.
about that?
So the white paper has a lot of information. We do expect the background task to start and stop, and you will get what is the equivalent of 2 seconds of CPU. You get 2 seconds CPU time every 15 minutes. So I'll repeat that. It's 2 seconds of CPU time every 15 minutes. It also means that your app was selected by the user who's in control, and he or she placed it on their lock screen.
And is that the same for keep alives also?
Yeah.
Yes.
For all background tasks. So
yes, we monitor, we track how much usage there is happening. We built new stuff for that, and we keep track of how many CPU cycles are being used up, and does give you what we think is the 2 seconds equivalent. And 2 seconds of CPU time is quite a bit. If you're doing any network I/O, for example, you're again blocking calls, so you don't count that after that.
Yeah, 2 seconds maybe is a max, so you enforce it, and maybe the guideline should be much shorter than 2 seconds of CPU time.
We think that based on what we've seen so far, we think that is quite a lot of time for you to get to do your app, whatever the app task is.
Yeah, my concern is more in power. 2 seconds of CPU time every 15.
So 2 seconds of CPU time every 15 minutes.
So we can
Right.
talk offline.
Yeah.
I know your concerns are power related, but the way the design system is such that we've actually budgeted the system so that it doesn't get total batch state. So it doesn't matter, even if everybody uses so much amount of time, we still have a guaranteed finite maximum for your batch
Yeah.
life.
So one point here is that everyone thinks that maybe their app is the most important one. Maybe it is, right? But in the end, it's the same battery, and so we all have to work together from the top stack, from the app right down to the hardware, so that we can achieve our longer battery life goal.
So I think it would be a good thing to chat with Hari here.
Okay, next question.
Hi, from a background task, can I execute an HTTP GET and parse it and then update a badge? Would that all be doable?
Absolutely.
Okay.
So you can make networking API calls, and you can do the badge update and throw a toast. Things that doesn't require the UI can be done.
Thanks.
So from background tasks, you said there's a limitation on the amount of time that you can use it every 2 seconds, every 15 minutes. What about something like a Pandora, like a streaming application? So
Right.
if you launch something, switch over to a newsreader.
Right. So let me paraphrase your question.
Okay.
What if I have an app like Pandora, which is wants to play music? So there's a different talk. I don't remember the number, but it talks about background audio, and there's references in Ben's talk also, which refers to how you can use audio APIs and what are these special things for that.
Now, is it just special for audio, or could it be some other type of stream, like something streaming to disk or something like that?
No, that's
No.
specifically about background audio.
Okay,
so your MP3 type scenarios, I want the music to continue playing, we support that.
But if you had something that was like downloading a file or streaming to disk, is there a separate?
That's a great point. You're asking about how to download a resource. I want you to look at another talk, which is about using there's a new API called the Background Transfer API. Again, the networking team has done that.
Okay.
And so your app can use the background transfer API. You don't need to be on the lock screen or anything. So you say, okay, go get me this URI, download this resource. You tell it, your app might get, you might still be foreground, you might be in the background, doesn't matter. The background task, the background transfer API will take care of downloading it for you. And once it's finished, your whatever function you've defined will get to execute.
Okay. I think I got some further questions afterwards then.
Sure.
Okay. My question is about the timer. Is it still working when system is in connected standby?
The time trigger?
Yep.
Yes, so the time trigger is allowed to work at all times. Like the fact that it's connected standby or active, it shouldn't matter.
Okay.
You should be able to use the time trigger.
Okay, thank you.
Okay?
Sure. Any further? So we'll be here, and a few of the other experts in the audience will also be here for questions. So if you guys have specific questions you want to talk offline, you can come and chat.